some issues with the one over there today.
All right, everybody. Thank you very much for coming out. We're going to get this party started. For everybody that doesn't know, my name is Travis, and I'm the president of the Marine Robotics Club. We have a seminar series tonight on 3D printing. It's going to be presented by our very own Justin Koenig. I want to give a moment and give a very special thank you to Christina Sai, who worked very hard to get us the refreshments that everybody is enjoying. We've got pizza, coffee, more drinks than we'll ever drink. But please drink, eat, be merry. And now, without further ado, Justin Koenig.
Woo! Hi, welcome. So, today we're going to be talking about 3D printing. Here I have my very own M3D. Ta-da. And today we'll be going over how to save a file from SolidWorks, but I really won't do that because I don't have it on my computer anymore. And then we'll show how to open up an STL file into a slicing program. We're going to do Cura. And then we shall bring that G code that we get from our slicing program into the M3D software. And we're going to see if it works. Lately it has not been working. It's being very difficult with me, so we'll see if we can get some results today. So we are going to start by going to a slicing program. We're going to open up Cura. Oh, before we even get there, we have to save a file, just like you would save any other file in SolidWorks, and save it as a SolidWorks part. There's a big drop-down menu. You could save it as an IGES file if you're going to bring it into ANSYS or any other analysis program, but you want to save it as a STL file, which is it's a mesh file. It takes your solid part and triangulates it.
Would you mind showing us how to do that? You think you could show us?
You think you get SolidWorks on my computer? I've been trying to get it working. It doesn't work. Too much of a hassle. We could go into that if you want to. Well, so that's how how I planned it. We're gonna find an STL file online. We'll call out someone, say, fine, we're gonna find something to print, and take you through the steps of printing. And then I'll do a Q&A. We could go over other programs and other types of 3D printing. We're mostly going to talk about extrusion 3D printing today. So let's go to Thingiverse. Thingiverse is a website by MakerBot, which is a 3D printing company. And people like to post 3D objects on there with the STL files. Anyone want something made? What do we want, guys? Someone raise their hand. What do we want? A rocket ship. Let's do some retro rocket ship. Good, I got some fuel next to it. We could strap to this. I'm going to download this thing as a zip. Yep. Let's start with the rocket body. So let's open up Cura.
Now, is Cura a free app?
Cura is a free program you can download from Google. It was originally made for Ultimaker, but now more and more printers are using it, especially the DIY community, do-it-yourself. We'll talk more about different types of printers later and prices of printers. So we're going to load a part. We downloaded. Oh, I'm all over the place. Where did it save to? Can I extract? No. We're going to download again. We never extracted. So we're looking for rocket body. So here is our rocket body. Ooh, ah. So as we see in Cura, we have a datum. This is our home. And we have our rocket body in the middle of the print bed. So this checkerboard bottom is the print bed. Then you have a cube that surrounds it. This is your building area. You can build to this max dimension. Now, this is probably set for an Ultimaker. I'll never really put it onto an M3D because for some reason this program does not want to cooperate with M3D. For me at least. So we'll go over all this quality, fill, speed, and more advanced settings. But looking at this part, one can see some issues. Usually when you 3D print something, you want to have structure underneath all the arms or things that are sticking out of the main body. Because you could have drooping or other issues. Now, because of this, there's a very steep angle here. We might not have an issue. But coming over here, we have quality. We could do layer height. This is how thick of a layer we want of it sliced in half. The lower the number, the more fine of a look you're going to get. The more fine of a cut you'll get. Shell thickness is how thick do you want your walls to be. I wonder if I can do layers. So it's building from the bottom. You can see how it's hollow on the inside. So this is the red part right here, red to the green. This is your shell thickness of your inner and outside diameter. So right now we have 0.7 millimeter. Under qual we also have enable retraction. Retraction is how much filament you want to suck back up into the nozzle. If we're moving from, if we're printing out multiple parts, you don't want to have a bridge connecting them, so it will suck the filament back in. Hopefully not leaving a strand behind, but usually sometimes you'll have a strand there still. Very, very light one. It's easy to cut off or sand off in the end. So minimum travel is how far a part has to be before it starts to retract. Z hopping is if you want your head to move up on the Z-axis before moving around. That could help with the retraction, help break the bond between the old layer and the new layer because you still have a liquid plastic layer right where your tooltip is. And minimal extrusion before retracting is how far it needs to move before that layer would need a retraction. Usually that really doesn't matter. Now fill is an important thing. I could show you guys parts. Of course my backpack's all the way over there. I printed out 2 cubes on the other printer with 2 different fills. And you could definitely tell one is definitely heavier than the other. I'll pass it around for you guys. Travis, can you see the difference between one is heavier than the other. One has a 100% fill, and the other one has a 25, if I remember correctly. 25. So that's if you want to save weight, but then you'll be losing strength in a certain direction, because it will give a different pattern in the middle. 100% fill will have a 45, a plus 45 to a negative 45 pattern, 9 degrees off each other. So you have one layer, you have a unidirectional layout, so your filaments will do a zigzag in one direction, and the next layer it will do a zigzag 90 degrees of where it was before, and then we'll repeat that pattern. It gives a nice lattice look.
Just a quick question.
Go ahead.
Would you mind changing the fill density a little bit so we can see how it affects the time of the print?
Correct. I shall. Going to 100%. We started at 4 hours and 49 minutes, and you will see the time should dramatically jump. You see now we have a part, there's no more of that yellow going back and forth. It looks like it's all green, but I think it's tooth and even matter. So for this part, it might not work. Oh yeah, here you go. You got your fill. Your yellow's a fill. Instead of little lines every once in a while, now you have a complete circle going around. And if we keep on raising, it's a solid yellow, all the way around. Now this part is hollow. And that's the end of it. Okay, so we're at bottom and top thickness. So this is where you start your print and end your print. So this is the walls of the top and the bottom. You want that to be similar to your shell thickness. We have 7 for shell thickness, and we have a 6.6 for top and bottom thickness. This is so it gives a 100% fill for the top and bottom if you don't have 100% fill density or a certain number fill density. So it gives you the solid look, just like like the cube, you have equal layer to wall ratio, how I printed those. Fill density, we already went over fill density. Go ahead. Are you trying to save weight? Are you making this for mechanical parts? Is it going to be moving? Do you need more strength? Unfortunately, I don't think there's enough research out there. Which, if I was going to do some sort of graduate school, I think that would be pretty cool to work on. Doing the strength and materials behind printed out parts with different densities, different patterns. But if you have a lower density, I wish I could bring in a cube. We're gonna get rid of this rocket for a second. Sorry, guys. Actually, we'll just pull in right next to it. I'm gonna bring in that 1-inch cube. Now, I like to make a 1-inch cube whenever I get a new 3D printer, because then I take that cube and I put if you see the cubes, I put a top, front, and right. This is so I can measure and see the errors from what it's supposed to be. It's supposed to be 1 inch every single dimension, but you can find out if you have calipers on you that it's off by about 14 thousandths of an inch. This is due to shrinkage or the belts being loose or some sort of mechanical error or software error. No. The rocket is, because you see there's a red wall layer. I wish there was a legend. Unfortunately, there's not a legend in here. Now I could bring my fancy program after this, and I'll show you more of the in-depths of different types of. There's more settings I could show you in that one. So here you got your speed and temperature. Print speed is how fast you want it to be if you're not going into advanced. Have everything print at 50 millimeters a second. Pretty quick. Printing temperature. Alright, so there's lots of different types of filaments out there, but the main two that people really worry about is PLA and ABS. PLA is a biodegradable after X thousands of years, which is, I don't really find that biodegradable, but it is. And ABS is pure plastic. They're both thermoplastics, meaning you can melt it down, it will solidify, but then you can melt it down again and solidify into something else. So to manufacture these spools, they actually take little pellets and they melt it down and they extrude them into a continuous line, and then they wrap it around a spool. That's how we have these filaments. I'm going to pass them around. You guys can take a look. Here's a one that's already open. There's different other plastics, but we'll go over that later. There's some pretty cool ones. They have composites. They have flexible composites. They got stuff thrown in. No, it's not composite. Alright, so printing temperature for PLA is around 210 to 220. Printing temperature for ABS is way higher. It's around the 240 to 260, even 280 range, depending on the type of plastic. And if some 3D printers have a heated bed, I advise if you are going to get a 3D printer, get one with a heated bed. This one does not have one. So if you're doing PLA, 70 is the perfect number. Doing ABS, you go way above to 100 to 110. It's half. Usually you want it a little below half of your printing temperature, just so your part adheres to the bottom. It keeps it warm enough that it stays sticky to the bottom. You have different support types. So going back to our rocket, we're gonna exit back to the normal view. Here's our solid part. I don't think it's gonna show, but touching build plate everywhere. Notice how we just went from 4 hours to 11 hours.
Real quick, earlier you were talking about the shrinkage, and that one is maybe says 14,000 per inch. Is that something you can build off of? Or if I make a piece that's 2 inches long, make it whatever.
Exactly. Last summer, when I really started to get back into the 3D printing, I used to do 3D printing back in high school, but I was a powder printer. We'll go over more of those later. I worked with an Ultimaker at the Hack Lab in Boynton Beach, and I printed out a couple parts, and I was saying, wow, this isn't fitting. So I took 0.003 of an inch off, and then things fit perfectly, spot on. Travis, do you remember that? It was pretty cool. Back here, we just went from 4 hours to 12 hours and 51 minutes. So now these fins will have a structure that's, of course I don't have any samples, structure that is kind of a corrugated plastic build up from the bed all the way up to your part. And usually it snaps off easily. Sometimes it doesn't and leaves little rough edges, but nothing that sandpaper won't help. Now, platform adhesion. We have a brim and a raft. A brim is a line where the nozzle will do a couple laps around the part build area to clean up the nozzle, to get the nozzle to start extruding a full extrusion instead of getting all the air out, so you have a continuous flow out. And then there's also a raft, which I do have. Here's a perfect one. This is a raft. This is a platform that your part will be built on. So it's a platform on the platform. This is because this is to help fight against the shrinkage issue, where if you take a look at those blocks, you see how they're kind of lift on the bottom. There was poor adhesion. This will help with adhesion, so the raft would lift and not your part. And then you have more settings for your raft, how thick you want it, how thick do you want your adhesion from your raft to your part, do you want a certain design. Of course, I'll show you all this stuff in my other program where you can actually see this working out. Unfortunately, here it doesn't really show you. Here we have filament. You get to put in your diameter filament. For some reason, Cura doesn't like 3mm filament, so it does 2.85. It's a normal setting. And here you choose your flow rate. Usually I keep it around 80, 90. You don't want too much of the goo coming out, or you'll get a little bubbling of filament on the sides of some of your prints. I don't know if you've seen some prints from the other lab, but some of the surface finish on the outside of some of the parts, there's some little extra plastic. If you're going to advance, if you are a crazy guy like me, this is where all the real numbers matter. So here you get to put your nozzle size of your printer. I actually found out this semester you could actually change that nozzle size for a fixed nozzle. So say you have a 0.3mm nozzle, that's what the M3D runs, that's what the Taz Spot 5 in my office runs with. But you could change the nozzle size and it will do a smaller flow rate out, so you'll get a finer line of plastic. Here we can actually go into retraction, pick a retraction speed and a distance of how much you want to pull back in. Here's a more of quality. We have initial layer thickness, your first layer. Do you want a thicker layer for that first layer? Initial line width of how wide you want that line to be. That's usually how far your nozzle head is from your plate. And your extrusion overlap. So if you're doing 100%, you'll have your one line, and then the next line will build a little bit on top of that one line to bond the two lines together to make one line. And here we have speed. What's your travel speed of your head when it's moving around between parts? 150 is fine. Now your bottom layer speed. Your bottom layer is always your most important layer because that is your adhesion to your bed or your raft. So if that doesn't print out well, your parts are not going to print out like this one didn't print well. So a low speed is really good. Infill speed, everything's set because it just initializes for first time in a while. There's no settings, there's all standard settings. Infill speed is how fast you want your infill design to go. Usually that could go pretty fast. You'd want that as your fastest print, as your fastest speed. Your top bottom speed I would keep similar to your bottom speed, your first layer speed. And the outer shell speed, once again, that's your surface finish look. Lower speed, the nicer of a look you'll have, but then too slow, you're putting out too much filament. So there has to be a right balance of flow rate and speed to have a nice surface finish. Inner shell speed, same as outer shell speed, and if you want like a shaft within a shaft to get things fitting. And cool is you could actually control your fan. All printer heads have a fan. M3D ones underneath. Usually gets in the way. Right here. Go ahead.
So this menu that we're looking at.
The advanced menu, okay.
These four options, basic, advanced, plug-in, start, and G-code.
Okay.
These options are specific for that 3D printer, or is this generic to Cura?
This is generic to Cura. I don't know which machine it's running with. It's running with the Lulzbot Taz. That's the one that.
Okay.
It's in there. I think it's the mini version. So this is to my printer in my office, which I will bring all of you to after if you would like to see what's going on in there.
But so now for other machines, that would have different options.
Correct.
This might look like it.
So you could install custom firmware. So bring in your printer if someone has already done all of that online. Or you could add a new machine and go through the whole installation and get to pick your dimensions. So for Cura, we bought 2 new printers for the lab, and they're the do-it-yourselfers. All the do-it-yourselfers are all RepRap machines. So you would select down here, and then you'll go down. And you'll enter in your dimensions of your print bed. Then once you have finished, you should get a new print bed size. You see how it's so much smaller? So go back to the tabs.